Hello there. Welcome to the Technovation podcast. Thanks for joining us.
Have you ever, heard that title, data scientist? Sounds kind of powerful, doesn't it? Maybe a bit mysterious. Definitely feels important for, everything happening now. It's been called the sexiest job of the 21st century, which is quite a claim. But what does someone with that title actually do all day? And maybe more importantly, if you're curious, how do you even become one? Today, we're going to try and cut through that buzz. We're doing a deep dive into this really great resource, the Aspiring Data Scientist's Guide to Success. Our mission: pull out the absolute key takeaways, the real nuggets of knowledge from it. We want to give you a clearer roadmap for understanding this field because, let's face it changes fast, from the basic skills right up to using them in the real world. Think of this as your shortcut to getting what it really takes. So let's say you're tasked with building something cool like, a movie recommendation system for a new streaming service. Where does a data scientist even start? Okay, let's unpack this whole data scientist thing. What does that actually mean day to day?
Right. Well, at its heart, a data scientist's job is fundamentally about using data, using it to find meaningful insights, make smarter predictions, and ultimately solve actual problems out there in the world. They're the ones who can stare at this mountain of raw, often really messy information.
Messy is probably an understatement sometimes, right?
Oh, absolutely. And transform it into something useful, something actionable. And their responsibilities, they're quite varied. It really starts with collecting and, crucially, cleaning that raw data, which, by the way, is a huge chunk of the job. Don't underestimate that part. Then, they explore for patterns, use visualizations to make sense of it all, apply statistics and, machine learning models to dig deeper. And maybe one of the most important bits, communicating what they find to everyone. Technical teams, sure, but also the non-technical folks, the business leaders.
That sounds like such a fascinating mix of skills. It's clearly not just about being good with numbers, is it? What makes it so unique in the tech world?
Definitely not just numbers. What's really interesting is the sheer breadth you need. It's this delicate balance, right? You need solid programming skills, good handle on math and stats, and then, just as vital, you need domain knowledge. Understanding the field you're actually working in, whether it's finance or healthcare or movies. The guide we're looking at puts it really nicely. It says, think of a data scientist as a detective who uses data instead of fingerprints.
Oh, I like that. A data detective.
Yeah, they're finding clues, solving mysteries, but their main tool is data. It's a common misconception that it's just coding. It's really about the whole problem life cycle, from figuring out the question to delivering an answer.
That data detective analogy really clicks. Okay, so if you want to become this kind of detective, what are the first things you need? The real foundational skills. What are those building blocks?
Right, the foundations. Well, a solid grasp of mathematics and statistics is pretty much non-negotiable. You'll need linear algebra, which, simply put, is kind of the language for handling big chunks of data organized, like spreadsheets or matrices.
Right.
When you hear about stuff like image recognition or, like our movie recommendation example,
right,
linear algebra is often under the hood, turning that raw info into patterns machines can learn. Then there's probability and statistics. That helps you deal with uncertainty, test ideas, hypotheses, and draw conclusions you can actually trust from the data. And calculus, especially concepts like derivatives and gradients, is key, because that's how many machine learning models actually learn, how they adjust themselves to find the best solution. You also need to understand statistical inference and regression. For starting out, places like Khan Academy or MIT OpenCourseWare are fantastic. Great first steps before maybe diving into more specialized courses.
Okay, linear algebra, calculus. Those can sound pretty daunting if you haven't touched math in a while. Is there a common hurdle there, mathematically speaking, that people hit? And how can they best prepare?
That's a really good question. I think a lot of people struggle with bridging the gap from theoretical math, class math, to applying it practically in code or to data problems. It's less about memorizing formulas and more about getting the intuition. Why does a gradient help find the best model fit? What does it mean? My advice: don't get too bogged down trying to prove every theorem from scratch. Focus on the why. Why this technique? How does it help with the data? Online courses often do a better job of explaining that practical intuition.
That's really useful advice. Focus on the why. Okay, so we've got the mindset, the data detective, and the essential math grounding. But where do you actually apply it? I'm guessing a lot of the doing happens with programming.
Yeah, exactly. Programming is where the rubber meets the road. Python is widely seen as the main language for data science now, and you need to get comfortable with its key libraries. Think of NumPy as your super fast math tool for numbers. Pandas is essential for working with data tables like powerful spreadsheets and code.
Pandas, yeah. Hear that one a lot.
Definitely. Then scikit-learn for your standard machine learning tasks. And if you're getting into the really advanced stuff, deep learning, you'll encounter TensorFlow and PyTorch. Now, while Python is huge, R is still very strong, especially for heavy statistical work. And SQL. You absolutely must know SQL for getting data out of databases.
SQL, okay, non-negotiable.
Pretty much, yeah. For tools, Jupyter Notebooks are vital for playing around with code and data interactively. Git is crucial for version control, like track changes for your code. And increasingly, you need some familiarity with cloud platforms, AWS, Google Cloud, Azure, because that's where the big data often lives.
Okay, so you learn Python, you grab these libraries. Is there a common mistake people make when they first start coding for data projects? A trap to avoid?
Yeah. A big one is trying to reinvent the wheel, coding everything from scratch, or jumping straight to the most complicated model they can find. Python's strength is its libraries. Use them. Another trap. Not using Git for version control right from the start. It saves so many headaches later when you need to backtrack or work with others. My advice, start simple, really understand the data structures and what the library functions are doing, and build those good habits early.
Right, good habits. We often focus on the exciting parts, like building those cool machine learning models, but you mentioned something earlier about cleaning data. There's this huge, maybe underestimated part about just getting the data ready. Our source guide had a pretty stark line about this, didn't it?
Oh, absolutely. Data handling and wrangling. It's paramount. This means cleaning up messy data sets. And messy can mean anything missing values, duplicate entries, weird formatting. Imagine dates written 10 different ways in one column.
Nightmare fuel for analysis, I bet.
Totally. It also involves something called feature engineering. That's kind of an art creating new, more useful input variables from the data you already have to help your models work better. You also need to understand the difference between structured data like neat tables and unstructured data, text, images, audio. And know how to handle various formats, APIs, CSV files, JSON, databases. The guide nails it with this tip, and it's just so true. 80% of data science is cleaning data. Embrace it.
80%. Wow, that number probably shocks a lot of people starting out. Can you give a quick example, like a common data cleaning headache and how fixing it really changes things?
Oh, sure. Imagine you're doing sentiment analysis on customer reviews. Your text data could be full of typos, slang, emojis, maybe even different languages mixed in.
Okay, yeah, chaos.
Or for our movie recommendations, maybe the movie titles have extra spaces or the release years are inconsistent. It's a mess. Cleaning isn't just tedious. It's like detective work itself, trying to standardize all that chaos. And honestly, that's often where you first uncover really important insights or biases hiding in the data that the noise was covering up. It's not glamorous, but yeah, that's where the real work often starts.
Okay, so the foundations are solid. You've wrestled the data into submission. What are the main things a data scientist is actually doing day to day? What are those core skills in action?
Well, the first major activity, and it's critical, is exploratory data analysis, EA. Think of it like getting to know your data really well before you build anything serious with it, like interviewing it.
Haha, interviewing the data. I like that.
Exactly. You use visualizations tools like Matplotlib, Seaborn, Plotly, Cadly to literally see patterns. You summarize things with basic stats. You look for weird outliers, trends, connections before you even think about models. It's about understanding the story the data is already telling you.
And then comes the part many people find exciting, machine learning. That sounds powerful. How do you break that down for someone learning? What are the main types?
Right. Machine learning, ML. It's definitely a central pillar. Broadly, you can think of it in two main categories. First, there's supervised learning. This is like teaching with labeled examples. You show the model data where you already know the right answer.
Like flashcards.
Kinda, yeah. It's used for things like regression predicting a number, like a house price, or classification deciding a category, like spam or not spam for an email. Common techniques are linear regression, logistic regression, decision trees, stuff like that. Then you have unsupervised learning. Here, the model has to find patterns on its own without labels, like giving it a big pile of photos and asking it to group the similar ones.
Ah, okay. No answer key.
Exactly. This includes clustering, using methods like k-means to group similar data points together. And dimensionality reduction techniques like PCA, principal component analysis. That's basically a way to simplify complex data sets by finding the most important underlying patterns, making it easier for models to work efficiently without losing too much info. And after you build models, you absolutely need model evaluation techniques. Things like cross-validation to make sure your model works on new data, not just the data it trained on. Confusion matrices, ROC curves for checking classification performance. And yeah, then you get into more advanced stuff like neural networks, NLP for text, computer vision for images.
That's a lot to take in. With all those different model types, is there a common mistake beginners make when they first start building ML models?
Oh yeah, a very common trap is called overfitting.
Overfitting, okay.
That's when your model learns the training data too perfectly, basically memorizes it.
Right.
But then when it sees new data it hasn't encountered before, it completely fails.
Like memorizing test answers but not understanding the subject.
Precisely. So the key is finding that balance between making the model fit the data well, but also making sure it can generalize to new unseen situations. That's where those evaluation techniques are so crucial.
It sounds like you could build the most amazing model, but if you can't explain it or show why it's useful, it kind of falls flat. So communication must be huge. Why is telling stories with data so important?
Spot on. Data visualization and communication are just as vital as the technical bits. This isn't just about making charts. It's about building useful dashboards, maybe with tools like Tableau or Power BI. But more than that, it's mastering the art of telling stories with data, not just throwing numbers at people.
Right, context matters.
Hugely. Imagine showing a busy exec a chart with 20 confusing lines versus one clear visual highlighting the single key trend impacting revenue. You have to tailor it. Technical details for engineers, high-level insights for business leaders making quick decisions. Storytelling turns those numbers into something people can understand and act on.
Okay, learning this stuff is one thing, but bridging that gap from theory to actual tangible experience. How do you go from reading the guide to actually doing data science?
Great question. The absolute best way. Just dive in and do it. Get your hands dirty. Our source guide actually lists some really good project ideas to start with. Things like building a basic movie recommender, tying back to our example, or predicting housing prices from data, doing sentiment analysis on, say, Twitter data, or using clustering for customer segmentation. These hands-on projects are where the learning really sticks.
And where can people actually do these projects? Where do they find the data and the platform?
There are some fantastic places online. Kaggle is brilliant. They have competitions with real-world problems, tons of data sets, and a huge community you can learn from.
Kaggle, right. Heard good things.
Definitely check it out.
Yeah.
Also, building your own portfolio of projects on GitHub is absolutely critical. The guide puts it perfectly. Your portfolio is your resume.
That's a powerful statement.
It really is. And you can find open data sets everywhere. UCI Machine Learning Repository, Google Dataset Search, government data portals, loads of raw material to practice on.
What makes a GitHub portfolio really pop for a hiring manager? Is it just having projects, or is there more to it?
It's more than just quantity. Quality and clarity are key. Your code should be clean, well commented, explain what you're doing, and ideally, someone else should be able to run it. And crucially, include a good readme file for each project. Explain the problem, your approach, the tools you used, and most importantly, what did you find? What were the results or insights? A portfolio that tells a story about how you think is way more impressive than just a folder full of code scripts.
Makes sense. So beyond the technical skills, beyond the portfolio, what does long-term success look like in data science? It can't just be about code and algorithms, right? There's more to it.
You're absolutely right. There are these other equally vital aspects. Networking and being part of the community are huge. Joining online communities, Kaggle forums, Reddits, Art Data Science, LinkedIn groups, attending meetups if you can, virtual or local, hackathons, conferences like PyData or NeurAPS. These are great ways to connect and learn. Even contributing to open source projects is a fantastic way to learn, collaborate, and, frankly, get noticed.
And what about those soft skills, the ones that maybe don't get as much attention but are super important? Which one do you think is the most underrated?
Oh, they're essential. You absolutely need a strong problem-solving mindset. You need curiosity. This field changes constantly, so you have to want to keep learning. Storytelling with data, like we discussed, is critical. And the most underrated, maybe cross-functional collaboration.
Working with other teams.
Exactly. Data scientists rarely work alone. You're constantly interacting with engineers, product managers, designers, business analysts. Being able to speak their language, understand their needs, and explain complex technical stuff clearly, that's invaluable for actually getting projects done and having an impact. The guide also maps out potential career paths, how you might go from data analyst junior data scientist Data scientist senior, maybe specializing later into machine learning engineer or moving into management with specific paths in NLP, computer vision, big data, and so on.
Okay, so the field moves fast. You need soft skills, community. Given all that constant change, how do you stay relevant? How do you future-proof yourself?
Yeah, data science is incredibly dynamic. Staying ahead means you just have to keep learning. It's not optional. This means things like reading research papers, places like ArcSave, or blogs from Google AI or Facebook AI are good sources. It also means exploring emerging areas like MLOps, machine learning operations. That's all about the practical side of getting models deployed and running reliably in the real world. It's a huge deal now.
MLOps, okay.
Learning big data tools like Spark and Hadoop is often necessary as data scales up. And critically, the guide highlights this too, understanding the ethics and fairness side of AI. That's becoming more and more important.
Are there any specific books or resources the guide strongly recommends for that ongoing learning?
Yes, it mentions a few classics that are great for digging deeper. Python for Data Analysis by Wes McKinney. He actually created pandas. Hands-on Machine Learning by Aurélien Girard is fantastic for practical ML. And Deep Learning by Goodfellow, Bengio, and Corville is sort of the foundational text for that area. Great resources for continued study.
Okay, so let's try to wrap this up. If you're listening and want to get into data science or level up, the checklist from this guide seems pretty clear. Learn the basics like Python and SQL, get those math and stats foundations solid, do some beginner projects, EDA, some machine learning, build that GitHub portfolio, maybe try Kaggle, network, apply for jobs, and maybe the biggest one, just commit to always learning.
Exactly. And connecting it back to the bigger picture, the final thought from our source guide really resonates. It says, becoming a data scientist isn't about mastering everything at once. It's about curiosity, persistence, and problem solving. The best data scientists aren't just coders or mathematicians. They're storytellers who turn data into action.
Storytellers who turn data into action. That's powerful. So considering that and thinking about the ethics point you raised, maybe the final question for you, the listener, is what kind of stories will you choose to tell with data? And how will you make sure those stories are not just impactful, but also fair and responsible? It's a powerful role and with great power. Well, you know how it goes. A lot to think about.
Thanks for joining us today. See you next week. Till then, like, subscribe, follow, and share to others. Bye for now.